let's understand this thing. So basically, let's understand what second law of motion is. So as you can see, the first statement that is written over here is the second law statement, Newton's second law of motion statement, that is saying the rate of change of momentum of a body is directly proportional to the force applied, and the direction of motion will be in the place, it will be in the direction of the force applied, right? So in terms of this equation, it will be like this. So force is directly proportional to the change in momentum, right? So change in momentum means there, everyone. So momentum means the product of mass and velocity, right? So it means that if a body is moving with some initial velocity, so initial momentum would be mu, multiplication of the mass and the initial velocity, because mass is not going to change at all. The second thing is that after applying the force on that body, the velocity will change, yes or no? Because external
Yes.
force is applied, it means that this uniform motion is basically broken. Uniform speed is broken because the force is applied, so the body will change its velocity, right? So the
Yes.
velocity will change from u to v, final velocity with some any, like it could be anything. So the final momentum would be m into v, that is written over here. The initial momentum was mu and the final momentum was mv due to the change in the velocity, right? So it okay. Now the statement is saying the change in momentum. The change in momentum means what? How to calculate the change? Final minus initial, right? That's how we calculate the change. That would be mv minus mu. Rate, whenever the word rate comes into the scenario, everyone. So it means that it is divided by time, right? So that's why it is divided by t. Mv minus mu divided by t. Is this clear to all of you? Bharti, Sarah, Heather, Arham, Arhan, and Hanan.
Yes, sir.
Okay, that's great. Now it means that they go. So now what I can do is that to simplify it a little bit, I have taken m as common because m is common right here because the body is same, the mass is not going to change at all. So what is left inside the bracket is v minus u and divided by the numerator, that denominator, that is t. So v minus u by t. So as you can see this thing, v minus u by t is a quantity that we have studied in the motion chapter. Can anyone tell me?
Acceleration.
Okay, after you said acceleration, what about Bharti, Haider,
Can
Sarah,
you
Arham?
repeat the question?
I'm asking what is the quantity represented by V minus U by T? Which quantity is represented by this?
Acceleration.
Okay,
Acceleration,
Arhan.
sir.
Acceleration. Okay. Sarah, Bharti?
Sir, acceleration.
Okay, that's great. Acceleration. Yeah. So that is acceleration. Okay. So the rate of change of velocity. Rate means divided by time, and change of velocity is the quantity that by which we are dividing, right? So, but v minus u by t is representing the acceleration. So that's why I can substitute acceleration word, acceleration quantity by v minus u by t. I can substitute it right here. Okay. So that's why m
Yes,
into
sir.
a. So that's how we got force is directly proportional to the mass. Basically, force is basically directly proportional to the mass into acceleration. So to remove this directly proportional, because we always study the thing in the equal sign. If we are going to say that this is the formula, so we are going to equate it. So to remove this directly proportional sign, basically one constant comes into the scenario. So that constant is basically k, and the value of this constant is 1. So basically the scientists have calculated and taken some other references and all. So they have calculated the value of k as 1. Okay. So now if I substitute it right here, so now that's how I will get the force is equals to ma equation. Am I clear to all of you?
Yes,
Yes,
sir.
sir.
Okay. So there is no need to like worry about how is it one and all. So because that is already calculated and that is not the part of your syllabus. Okay. So the thing matters is force is equals to ma. Okay. So now everyone, you can see this thing that mass of a body is not going to change at all. Mass would remain same, right? Yes, sir. Say yes. No, mass would remain same or not?
Yes,
Yes,
sir.
sir.
If you are taking a single body, so the mass will remain same. So it means that you can see that acceleration and force are directly proportional or directly linked to each other. It means that if you increase the acceleration, force will increase. If you increase the force, acceleration will increase. So both are directly proportional to each other. Am I clear to all of you?
Yes, sir.
Any doubt
Yes,
so
sir.
far to anyone? Okay, that's great. So basically, the second law of motion gives us the relationship between the force and the acceleration. That's why it is important. Okay. Now, next thing. So now the acceleration produced in the body is directly proportional to the force acting on it and inversely proportional to the mass of the body. So now let's understand and analyze this thing, everyone. So as you can see, this thing, acceleration can be written as force by mass. So as you can see, this thing, that acceleration is directly proportional to the force, but it is inversely proportional to the mass. So let's take one example, everyone. Suppose that a force, we are taking two bodies, like mass 2 kg, mass 10 kgs. Okay. Force applied on the body would be same. Now, how to calculate the acceleration? It would be F by 2 acceleration for the 2 kgs and acceleration A dash F by 10. Which acceleration is greater and how? F by 2 or F by 10? Yes, everyone, tell me. Which acceleration
F
is
by
greater?
10 is good.
Okay, let me know in the chat, everyone, fast. F by 2 or F by 10? Fast. Hanan, Arham, Arhan, Sarah, Afrin, and Heather. Okay, Arham said, ठीक Okay, Hanan. Okay, Heather. Okay, Sarah. Afrin, Bharti. Yeah. So F by 2 will be greater, everyone, because the denominator is small, so your fraction will be high. If you are dividing 5 by 2, suppose force is 5 Newton and another force that is also 5 Newton and divided by 10. This is 2.5 and this is 0.5, everyone. So that would be greater, na? Smaller the denominator, higher will be the fraction, everyone. Clear? So that's
Yes,
why
sir.
if you're going to increase the mass, it means that acceleration produced in that body would be less. Okay? If you increase the mass, the acceleration produced in that body would be less. Clear? And if and you can see this thing as the mass of the body is 10 kg, that means that the acceleration produced will be less. Is this clear to all of you? Please do let me know, everyone. So that's how they are
Yes, sir.
linked to each other. Okay, so if you increase the mass, the acceleration produced will be less. Okay, shallow, that's great. Next is force is a vector quantity. So force depends on both mass, magnitude and the direction, right? So it is a vector quantity, so it depends on both. Anyone, any doubt so far till now, everyone? Please do let me know.
No, sir.
Sure, that's great. Okay, SI unit of force is Newton. So basically the SI unit is uh, given in the honors of the Sir Isaac Newton. Okay, so that is Newton. So if we define 1 Newton of force, everyone, so it would be 1 Newton of force is that force which, when acting on a body of mass 1 kg, will produce an acceleration of 1 meter per second square in it. So if a body is if 1 Newton of force is applied on it on a mass of 1 kg, so acceleration produced would be 1 meter square. Clear?
Yes,
So
sir.
this could be a question that define 1 Newton in the exams. Define the force of 1 Newton. That could be that could be a question in your exams. So these are the very small things that you have to consider while revision. Okay, while revising the things. Okay, Afrin, Arhan, Heather, Sarah, Arham, and Bharti. Hanan.
Yes, sir. Clear.
Sure, that's
Yes,
great.
sir.
That's
Yes,
great.
sir.
Okay, that's great. Now let's understand the applications of the second law of the motion. So sometimes what happens is that sometimes instead of question, the question comes as conceptual questions in the exams, because second law of motion is basically you can say is based on the numerical portion, right? But in the exams, this could be a decisive portion for you. So that is the applications. So the catching a cricket ball, how it is related to the second law of motion. A cricket player moves his hand backwards on catching a fast cricket ball to prevent injury to the hands. So ball is there. First of all, ball was moving with some large momentum. Initial velocity was something. But suddenly when you catch that ball, the momentum is reduced to zero because the velocity of the ball will be zero in that case. When you catch it, the ball will stop. Yes on everyone. So the change in momentum would be whatever the velocity of the initial ball is minus my final momentum, right? So as you can see this thing, a fast moving cricket ball has a large momentum. In stopping this ball, its momentum has to be reduced to zero. A cricket player moves back his hand in the backward on catching a fast ball to increase the time to reduce the momentum. If you increase the time to reduce the momentum, this is the equation. Change in momentum, we are going to basically change this thing. So if we are basically increasing the time to reduce the momentum, force applied would be less or high on the hands. Please tell me, force applied would be less or large in that case. Afreen, Heather, Bharti, Hanan, Raham, Arhan, Sara. The force is inversely proportional to the time in this case, na? If you talk about the change in momentum, right? So it means that if you increase the time of basically time to reduce the momentum, so that will basically gives you less injury because time is here. So force applied would be less. It will not be higher. It would be less, right, everyone? Okay. So that's why we take our hand in the backward direction so that we can increase the time to reduce the momentum. So that will not hurt at that much. Okay, with that magnitude. Suppose let's take an example if you're not getting it. So change in momentum already given in the question, right? That is 50 kg meter per second, right? Two times are recorded. Time one is basically 0.5 second and time two is basically 2 seconds. So two times are recorded to find out which one will hurt more. Whether if you basically suddenly stop the ball, will that hurt more? Or if you take a little bit time or take your hands in the backward direction, so that will be taking long time. Because 2 seconds, if you catch it and take it in the backward direction, that will take a little bit more time, right, everyone? So now let's divide that force is calculated by change in momentum by time. So delta P, change in momentum, I'm writing it like this, and T. So 50 by 0.5. 10, this will cancel this 10 cent. So 10 into 10 would be 100 Newton. It means that in the first case, the ball will exert 100 Newton of force on the hand. Am I clear till now, everyone?
Yes, sir.
कुछ तो बोलो. सब clear है ये?
Yes, sir.
Example, Afrin, Arhan, Arham, Haider, Sara, Hanan. Right? Afrin,
Yes,
is it
sir.
clear?
Yes, sir.
Okay. Now let's take the next case, right? Another force that would be delta P. You can say change in momentum divided by time. So that is 50 divided by 2. That is equals to 25 Newton. Which force will hurt you more? Which case? If suddenly you stop the ball or if you take a little bit time? Please do let.
Stopping the ball.
Yes, Bharti, you are saying something, Bichin? Yeah, please do let me know which one. F1 or F2? Which one will hurt more, everyone? The answer is in front of you.
F1.
Please do let me know.
F1.
F1 or how? F2 by Afrin. F2 you are saying, Afrin? Okay, Heather. ठीक है. Sara, Bharti, Afrin, Arhan. Which one will hurt more?
F1.
F1. F1. ठीक है. Obviously, 100 Newton force is greater than 25 Newton. It is 4 times. Right? It means that if you suddenly stop the ball, that will hurt you. Right? So that's why you can see this thing. If you increase the time to reduce the if you increase the time of change in momentum, so that will basically hurt you less in comparison to if you suddenly stop the ball. Clear, everyone? So that's why I have taken this example so that you can understand in the calculative manner, right? So that's why we take our hands in the backward position to stop the ball so that we can increase the time to reduce the change in momentum, right? That will basically ultimately reduce the force on your hand by the ball. So they can reduce the amount of force is exerted. So when then the time taken to reduce momentum of the ball is increased and a small amount of force is exerted on the hands of player, so the hands do not get hurt. Okay. Next example is the seat belt. Seat belt is one of the most common example, and this is a very common question in the exams. That says, sorry, that says all the cars are provided with the seat belt for passengers to prevent injuries in a car accident. In a car accident, fast running car stops suddenly. So if basically the car is moving, that is some velocity mu, momentum mu, suddenly the momentum is changed to zero. If you suddenly change the momentum to zero, you will basically experience a large force because the time taken to change the momentum is very small, right? So that in that case, you will fall in the forward direction due to inertia and your head will collide with the dashboard or even severe injury. Even the person would basically come out of the car, right? If the car is traveling with a very high speed or large momentum. So that's why the seat belts are given to you so that when you go in the forward direction, it increases the time to reduce the change in momentum. So that's why the less force is exerted on the body, or maybe you will not get that much severe injuries. Get it, everyone? That's why the seat belts are very important in the car. Okay, whenever you are traveling, please basically put the seat belts on your chest. Okay. Sometimes this class is an awareness class as well. So due to this car, large momentum is reduced to zero in a very short amount of time. The slightly stretchable seat belts worn by the passenger of the cars increases the time taken by the passengers to fall forward and less stopping force act on the body, right? So these passengers may either not get injured at all or may get less injuries. So two reasons. So if maybe this could be a reason that the person like will not get injuries, but in that case, if the body gets collide or basically hit on the dashboard, so this injuries will not be that much severe, right? Please do let me know everyone if it's clear to you or not.
Yes, sir.
Yes,
Yes,
sir.
sir.
That's great. Just a second, I'm sharing my screen again because I have to erase a part right here. So that's how these are the questions that could be there in your exams. Okay, asking like basically in terms of second law of motion, like we have already discussed the first law of motion examples, right? That why the dust particle come out from the carpet, hanging carpet, if you beat that with the stick, or one more example that car, how do we walk, right? So if we exert, no, not how do we walk. One more example, just forget, not able to remember that thing. It's basically dangerous to come out from a moving bus, or what happens when a car suddenly stops or start, right? So these are the things that is there in the first law of motion. In the second law of motion, the use of seat belts, catching a fast cricket ball. So these are the things, right? So there are some basic examples like how to implement the formula. So basically what force is required. So force is acceleration is 4 meters per second square in that case, and mass is 6 kg. So you just have to multiply it so that you can get the proper answer, right? So 6 into 4 will be equals to 24 of Newton, right? And one more thing, and see, and I have seen this thing very, very frequently that if, like some of the students do not write the units in front of the quantity. So if you are not writing, so teacher is going to basically cut your marks definitely, even 1 marks. Sometimes teacher deduct 1 marks for that silly mistake. So that would be like you will be responsible if you're not writing the units, because physics is all about units, right? So if you do not write it, marks will get deducted. Okay. So please and please make sure of that thing. Okay, next question. What acceleration will be produced if the force applied is 12 Newton and the mass of the object is 3 kg? So acceleration could be find out by dividing the force by mass. So force is 12 Newton, mass is 3 kg. So that would be 4 meter per second square. Okay. Now the question is basically, okay, please do let me know the answer for this one, everyone. Just listen. First, look next. The graph wala question I will give you so that you can solve it. Okay. And do let me know the answer first. And answer me in the chat only. Do not mute yourself and okay, I got the first answer by, let me check. Bharti. ठीक है Bharti. What about the rest of you, बच्चों? Afreen, what's the answer? Farhan, Arham, Sara, and Heather. Hanan. Hanan, are you there in the class, बच्चे? Okay, Afreen. Afreen, it is Javi or Zabi. Actually, when you, yeah, I'm like a little bit confused in that because in the start of the trial class, you used Zabi.
Javi.
Javi, अच्छा Javi.
Yes.
Okay, okay, कोई बात नहीं, ठीक है, okay, Afreen. Okay, Sarah, answer. Arhan, Heather, Arham. Okay, Arham. Okay, Sarah. Oh, that's great. Good, good. Heather, any answer? Okay, Heather. Oh, okay. Bharti, you got. अच्छा, Bharti gave the answer first. ठीक है. Hanan, any answer, बच्चे? Hanan is facing very frequent internet issues. So that's great. So let's solve करते हैं इसको. Arhan, any answer? Arham, have you given the answer, everyone?
Yes, sir. I have.
Check, check, check. Okay, that's great. Okay, now let's solve it together. The question is saying that calculate the force required to impart a car to a velocity of 30 meter per second in 10 seconds, right? Mass is already given. So car is starting from the rest. Okay, the question is saying this thing. And the final velocity is 30 meter per second, right? And the time taken to impart that velocity is 10 seconds. It basically the change in velocity is 10 seconds, right? So we need the acceleration. We need the acceleration to calculate the force because force is nothing but mass into acceleration, right? So we can use one thing, like we can directly write force as force is equals to m into v minus u by t, or we could sorry, we could use the acceleration. Basically, we could find the acceleration first, then substitute in the formula. So now we are going to find the acceleration first. That is v is equals to u plus at. So v, so u is basically 0, and just a second. 30, 0 plus 10 into a, right? So a would be equals to 10 by, sorry, 30 by 10. 0 will cancel this. Ultimately, the value coming out will be 3 meter per second square, right? Next is we need to find the force. So force would be F is equals to M into A. So for 1500 into 3 would be equals to 4500 Newton. This is the answer. Heather, you did a mistake in the calculations. Okay. Any answer to anyone? Please do let me know, everyone. Is there anyone who is having doubt in this question? Please do let me know, everyone. Chalo, that's great. Now I'm going to give you one more question. Please do let me know the answer of this question. This is a question based on the graph, and this question would be a 3 markers in your school exam. So please do let me know the answer for this one. Fast. Answer me in the chat in a single message. Do not write this like specific answer like one is this and another one. So when you will be solving with both the questions, so you just write the answer in the single message. Afreen, Heather, Arham, Sara, Arhan, and Bhakti. Hanan as well. Okay. Please do let me know first. Okay, Arham. Arham, which unit is it? Minus 15 meter per second. The question is asking about the force, Arham, not the speed. I don't know what it is. Please check it and do let me know again. Check it. Please check it and let me know.
Oh, sir.
Check it. Okay. Okay, Bharti. Okay, Helen. Just a second. Let me check the other answer. That is good. Check it. Arhan, are you there in the class? Arhan? Oh, he has left. Afreen, any answer? Bharti, have you given the answer? Check. Okay. Okay. Now let's solve it together, everyone. Please look at the screen. Have you given the answer, Hanan?
Yes, sir.
Check. Now let's verify who got the right answer. So everyone, you can see. Achha, one more thing, everyone. Please do let me know in the chat that which motion is performed by this BC phase, BC area. What type of motion is this? In the chat. Accelerated, rest, uniform motion. What is the answer? Please do let me know. Okay. Okay, sir. Okay. You gave the answer first. Bharti, Afreen, Heather, Arham, and Hanan. Answer it wisely. I'm again asking it. Which kind of motion is basically represented by the line BC? Accelerated, rest, or uniform motion, or non-uniform motion? Fourth option is also there. Okay, Afreen, you gave the answer. ठीक है, Arham. ठीक है. Okay. Okay, Heather. Afrin, what do you say? And Hanan? Okay. Afrin, any answer by you? No, I'm asking about the like, okay, that's good. I'm asking about the graph, that what type of motion is represented by the line BC in the graph? What type of motion? Accelerated, uniform, non-uniform, or rest?